Hello everyone, so today we are going to Leetcode daily challenge with number. So in this question we are given with an array containing n distinct in the range 0 to n. So as it is given that it is in the range 0 to n, so numbers would be something like 0, 1, 2 up till n. And all the numbers are unique also, no duplicate is there. So here n distinct elements, the only number in the range that is missing from the array. So there would be some number which is missing from this array, right? So that we need to find out. And there is only one number which is missing. So this is the question which we are required to do. Now comes the part about the constraints. At what constraints we are given with, let us have a check. So it's n raised to the 4. So basically n solution would work as even n log n solution would also work. And all the numbers are in the range of this only, means this one, as they have mentioned that they are in the range 0 to n. Okay, so now let us take examples and then I'll walk you through this means methods which could be used here. So now comes actually there are 4 methods which could be done for this particular question. So but from the one which I came with was only one, means when I saw this question I got to know like this is something related to this mathematical portion and like that, because the numbers are unique and they are in this range and only one number is missing, so we could do the mathematical part and it could come up with that thing. But yeah, there are some more methods also. Let me explain you that also, then we'll come up with that particular solution. Now here comes what 3, 0, 1, right? So if we sort it, so we would be able to get 0, 1 means this is the number which is missing, right? So if we sort it, it will be like this, right? So after sorting, what we can see is that at 0th index we are having the same number. At one index we are having the right number, but at last index it is required to have 2 here, right? But 2 is not there, and the last index is already having the length of the array, that is 3, right? So in this context the missing number is 2. Now for this 0 and 1, again it is at its right index, it is at its right index, right? But this particular is not representing length of array, right? Because our length of array is 2, so it is not representing that 2. So that's why here not this one but this 2 is the missing number. There were conflicts and which we are required to solve. Here now if we sort this 0, 1, 2 is there, 3 is there, 4 is there, 5 is there, 6 is there, 7 is there, 8 is not there, 9 is there. Okay, so all of them are at their own index. Only here 8 should be there, but this length is given, right? So here 8 is the missing number. So like this, the first method here is while sorting. Means we need to sort this particular array, given array, and then we need to compare with the index. If index are same, then it's all right. But if at the last index we are having a number which is either equal to length, right? But the index and the number are not same, then that index is the answer. Or if the length of the last number which is being given to us, right, it is not the length of the array, right? So we need to return the length of the array. Means these two examples I am talking about. Here we are required to return length, and here we are required to return that last second number which was there. Better we can say it as the mismatch number. Here we were required to return mismatch number. So this is the first method, means the method 1, which is our sorting. So as we are sorting, right, means first we are sorting, so that's why it is order of log n, and then traversing the whole array, so it becomes n into log n, and the space complexity here would be order of 1. So this is about the time complexity and space complexity of our method 1 and the way it is required to be done. Now comes the part for our method 2. Now our method 2 is something like this, means method 2 would be hashing. So while we do hashing, in hashing we are not required to have something in sorted manner, right? Those hash sets and in Java and in C++ and ordered sets. So they're not required to be in ordered manner. We are only required to have them in such a manner that we could have a lookup in them, right? So for that purpose, we are using hashing. So now the thing would be, what we would be doing is, first we will simply put every element in this hash set. These all the elements of nums which are there, I'll put in this hash set, right? Now the second thing which we would be doing is, we'll simply run a for loop, and that for loop would be from I equals to 0 till n minus 1. This is what we would be doing in this hash set, and then we would be comparing the index. Basically this is index, means index I. We will be comparing this with this hash set. We'll check that if this index I is really exists in the hash set or not. Wherever we'll encounter that if I is not equal, but if I is not contained in this hash set, right, then we'll return that I. Else all the elements would be there, the way here all the elements were there, but there would be the last element, that is 2 here, basically the length. If that length means if this particular is done, then we'll check, means if it is not exited from this, then at the last we'll return the length, because that length was the only element, means the last element was there, which was not in this hash set. This is which we are required to do in this second method. And as it is hashing, so order of 1 would be for lookup, but we are running a for loop. For that purpose, our time complexity becomes order of n, and our space complexity is order of n. Why? Because of this hash set which we would be using as an extra. In the previous method which we were doing, that also the space complexity can become order of n also if we use a extra means extra array or vector, we use that then. Because the thing is, we were sorting in place only, means in original one only, and if the interviewer says you that you are not required to modify the input array, then you would be obliged to have a separate vector, right? So that in that sense, there also the space complexity would be order of n only. So this was our method 2. Now let us come to method 3. Let me show you on the whiteboard itself. Oh, this is not good. Okay. So our method 3, by bit manipulation. How bit manipulation? We can see that in our example 1, we were having array which was something like this, 0, 3 and 1, right? Example 2, our array was something like this, 0 and 1. In example 3, our array was something like this, 0, 1, 3, 2, 6, 7, 4, 5, 9, right? So now Now how bit manipulation would work here? We will use basically XOR operation here. Why we will use XOR operation? Because when we do XOR with the number itself, right? If we do XOR with 0 into 0 or any number if you can take, because 0 is having some other properties also, so that's why. If we do XOR with n into n, means if we do XOR with itself, then it returns us as 0, right? If we do XOR with any other number, if we do XOR n with x, then some other y number is returned. But if we do XOR x with y, then n would be returned. So using these properties we could use here. Now, how come we could use bit manipulation is, if we do, here the thing would be, we are also having some indices, right? We are having length also with us, right? So in that context, what we would be doing, we will be having our length. We will do XOR with present index, and we will do XOR with whatsoever our present element is there. This would be a repetitive process which we would be ongoing with. Means okay. Means whatever a missing number is there, we'll basically initialize it with length that we would be doing here, right? So our main purpose at each step would be this only. So missing number would be something like this: missing number, and we'll do missing number was initially having length, so it will be done with this, and then I, and then nums of I. Now how this would work, let me show you. So if we take example of that 0, 1 and 3, right? Now here length is basically equals to 3, right? So our algorithm would work something like this: missing number equals to missing number, length was 3. Initially this was equals to length only, right? So which was equals to 3. So now in loop, means in for loop, and that for loop would be from I equals to 0 till n minus 1. So missing number equals to 3 XOR with I, that is 0, XOR with nums of I, that will also be 0. 0, 1, 2. So nums of I is 0. So it will be 0 here, right? So now next 0, 0 would be 0, and 3, 0 would be 3 only here, right? Now comes the next part, this one, right? So our index is 1, number at that index is 1, so it will again be 3. Now it comes this part. Index is 2, our number is 3. So 2 or 3 would be some number, but when we do XOR with that number with, means this would be some number x, and if we do XOR of x with 3, and 3 was already there, so it will return 2. So that's why here it would be 2. And we'll end up the loop here only because this was the last element, means this 3 was the last element. So our missing number would be 2 here. So this would be our answer. So like this we would be doing our XOR operation here. Basic XOR operation, because of the properties which I had mentioned above. So because of that we will be doing XOR here. So the time complexity here would be simply order of n, and the space complexity is order of 1. Why order of 1? Because of the fact we are not using any extra space. Now let me walk you through the fourth method which is being there. So let me use another pen. So method 4. This is what I was saying, the one which we use to have in our junior classes. So 1 and 0, and here 0, 1, 2, 3, 4, 7, 6, 9. So here what we would be doing is, we know that they are unique, right? So how we can do is like, and we are having n value. Basically length we are having, right? So our length is 3. So when we in our younger classes how we did the sum of natural numbers. So sum of natural number is something like this, right? So because of this, we'll get that sum of this particular array which should be. So its sum should be something like this. 1 plus 2 plus 3, that is 6, right? But what sum we would be getting because of 0 which is being there? It will be something like this, right? So what number is missing here? That is 2. So this is the whole logic which we are required to do here. So what we would be doing is, we will simply do at the first step, n into n plus 1 equals 2. This is our expected sum, right? This is what we would be doing. And second thing we would be doing is, we are required to find the actual sum which is there, right? That actual sum would be from aggregation of whole array with whole input array. So that will give us the actual sum which we are having. And the third point would be, we are required to return expected sum minus actual sum. This is what we would be required to return. So this will give us our answer. So doing all this, our time complexity is simply order of n, and our space complexity is simply order of 1. So bit manipulation and the sum method are the two methods which are the most optimized and most expected ones. Yeah. So now let me walk you through the code. Basically here I've coded only one method, that is our last one, because I came up with this one only. Other ones I was required to derive from these methods. Basically of that bit manipulation somehow came from this one into a while because of the missing numbers and uniqueness. So what at the starting I'm taking is, we are taking the length which is required to us, and then the given sum is basically this one. I've taken it as given sum, and there I was using that as actual sum. Now total sum, which should be there, means expected one. So this is how we will be calculating that given sum, and then at the end we would return this total sum minus given sum. So like this, it is order of n, order of 1 solution. So like this it is there. If you want to go ahead with that bit manipulation, here what we are required to do is, we would be simply required to do means if we take missing number as the variable, missing number, then your equals to I, then your nums of I. This is what we would be doing here for that bit manipulation part. And our given sum and that missing number should be initialized here as n. This is what we would be doing here, and here we would be returning our missing number. This is what we'll be doing here. So this is all for this particular question. I'll attach a solution for all other methods also. So you could check that GitHub repo also for this thing. So this was all. So thank you.